information-rich world, the problem is not so much acquiring information, the problem is more making sense of large amounts of it. In our user interface research group at Xerox PARC, we've been exploring the use of information visualization to produce new kinds of documents in new user interface paradigms that allow people to deal with much larger amounts of information than previously possible. Recently, Ramana and I have turned to the problem of dealing with large tables.
For example, this is a table of the 1986 baseball statistics with 323 rows of players and 23 columns of data. We can put the data into a spreadsheet, but even using a 21-inch workstation display, the data requires 9 full-screen vertical scrolls and 2 horizontal scrolls, making it hard to work with. It's hard to find players or see interesting patterns. In short, it's hard to make sense of the information. We've devised a new way of visualizing and interacting with large tables called the table lens, which exploits graphical representations to compress the information onto the display. In this column, at bats, we integrate a familiar bar chart representation directly into the textual view of a table. Some of the rows, those in focus, show underlying textual values along with the graphical bars. Other rows, those in the context, show only graphical representations, thus requiring less space. By displaying the entire table graphically, with only some of it in focus, this 324 row by 24 column table can be shown using a portion of the screen. The table lens displays 30 to 100 times as much information as a spreadsheet in the same space. With a small set of manipulation operations, the table lens allows fluid navigation and exploration of the data. The focus area can be manipulated using control points and/or keyboard commands. The number of cells in the focal area can be increased or decreased. The focal area can be moved to different rows or columns. Since the essential geometry of the table is preserved, multiple focal areas can be created. To facilitate browsing of context cell values, a mouse feedback area at the bottom of the window shows column, row, and value information. The graphical representations make it easy to spot trends and patterns and to isolate outliers or unusual cases. For example, sorting a column can reveal relationships to other columns. Here, sorting career at-bats reveals correlations in several nearby columns. Notice that career hits is strongly correlated or proportional to at-bats. In other words, most players have similar batting averages. Some players stick out from the curve, 2 well-known batting stars, Wade Boggs and Don Mattingly. To confirm these observations, we divide career hits by career at-bats, creating a new column, career average. The batting average curve is reasonably flat, as the correlation of the curves suggested, though increasingly noisy with decreasing career at-bats. Furthermore, the length of the bars shows that Boggs and Mattingly have the highest 2 career averages. If we focus on the salary column, we see that Boggs and Mattingly are paid relatively well for their top-flight batting performances. Also note that salary is somewhat correlated with career at-bats. Team and position of a player categorize players into different groups. Category values are displayed using blips. In focus columns, the blip is colored and positioned in the cell according to underlying value. In context columns, since space may be tight, only color is used to indicate the value. Sorting on position separates the players by category. In other words, all like-colored and positioned blips are brought together. So this red line is all the third basemen. Coding effects can be readily spotted. These isolated blips indicate players that play multiple positions and thus have unusual position codes. Sorting by team, other interesting patterns emerge. First, we can see that each team carries a complete stable of player positions and that the sporadic blips are scattered. Second, notice that most of the teams have the same number of players, though 2 lines are about twice as long as others. This is another coding effect. These lines are Chicago and New York, both of which actually have 2 teams. Nearby, 2 other category columns, division and league, have become more orderly, indicating a relationship to team, or in database speak, a functional dependency. Since the noisy areas align with the Chicago and New York players, perhaps we can exploit these variables to separate the merged team codes. In this next scenario, we perform a common kind of analysis in which quantitative data for different categories is compared. First, we sort position and hits to obtain the distribution of hits for each position. Comparing these batches, the second and third from the bottom stand out somewhat as having more large values. These are the first baseman and right fielders. Reasonable positions in which to place strong hitters with less than stellar fielding skills. Other nearby columns show some dominant groups. Further investigation reveals that these columns are putouts in which first basemen and catchers dominate, and assists in which the infielders dominate. An alternative for observing the relative performance of a category utilizes a technique called spotlighting. The blips for players of interest are accentuated using a red line, and then the quantitative column of interest, hits, can be sorted, in this case revealing that the right fielders band toward the top of the distribution. Here, we look at Xerox stock data for 492 trading days. This table has columns for date, volume, high, low, and closing price. The graphical representation for dates is similar to the one for category variables. Each month is given a span in the column, and 3 colors are used for the first, second, and third months of a quarter. Thus, we can see that the table includes just over a year and a half of data. Blank lines in the data indicate trading holidays. These 2 nearby lines must be Christmas and New Year's Day. We can explore the relationship between daily trade volume and daily price range. First, we calculate the daily price range from the high and low, and then we sort by volume and break the table into quartiles. We can see that most of the really high range days are in the top quartile of volume. By reordering by date and calculating closing price minus the previous day's closing price, we can examine the daily change in price. And now, sorting on the change, we can view the top change days. By sorting volume, we see where these big change days fall on the volume distribution. Most appear on big volume days. The well-known buy signal sought by technical traders is a large jump on large volume days, in fact, like the days currently selected. By sorting on date, we can examine whether Xerox stock rose in the period following these technical indicators. Here, we see that the recent Xerox price climb started from a pair of these big jump, big volume days, and 4 others occurred during this rally. Here, we have 406 cars sorted by gas mileage. The Japanese cars, indicated by red lines, dominate the high MPG cars. An unexpected advantage of table lens is that sorting is useful for navigation as well as analysis. Let's say that we want to find the Toyota Cressida and we know that it's a Japanese 6-cylinder car. So we sort by cylinders and then by origin. We can then focus on the Japanese 6-cylinder cars to find the Cressida. Though textual search may be faster, this technique will work without a keyboard, for example, with a pen device. Furthermore, sorting organizes the nearby space. Here, other Japanese 6-cylinder cars are now nearby. Thus, this direct manipulation technique provides capabilities similar to a hard-to-use relational database query.
The looming advantage of the table lens is the space advantage. You can visualize and manipulate this much information and more on a single integrated display.
The table lens also makes it easy to navigate around a table without getting lost, to perceive patterns or find interesting cells, and to explore relationships between cases and variables. In short, it allows running your fingers directly through the information, making sense of it.